Hello everyone, in this video I'm doing the exercise on slide 11 of lecture 5. I want to solve the modified TCP problem by defining sets and parameters in Gusek. Since we already done the TCP problem in our previous video, I'm gonna select all of these code and use them here in my new model, because it's very similar. This model is very similar to our TCP problem. We just had 3 more variables and we need to modify the constraints. So I'm gonna use that code. In previous video we already did it to solve the modified TCP problem. Let's see what is different here. Again, we have set j and set I, j for decision variables and I for constraints. J is the set of x variables. Now here we have y variables too, but for each constraint we have one decision variable y. So for constraint y we have y1. For constraint 1 we have y1. For constraint 2 we have y2, and so on. So the index of y as a decision variable here is I. Was for constraints. Now we can use it for decision variable y. y1, y2, y3. So we don't need to define a new set. We have j and I. It's enough for us for this model. You need to define a new parameter. Cj is for the coefficients of x variables in objective function, but here we also have coefficients for y variables in the objective functions. So I'm going to define a new set of objective function coefficients. Let's call this C1. Let's call this C2. What is the index of C2? It's Ci. This is 20 and 15 for parameters C1, 10, 14, and 8, negative 10, negative 14, and negative 8 for parameter C2. OBJ coefficients for x. I'm going to copy this and paste it here. OBJ coefficients for variable y. Okay, don't forget to change your parameter values in data section. It was C, now it is C1. Now I need to define C2 as well. The index of C2 is I, so you need to define a value for each of the entities in set I. For entity I equals to 1, the value is negative 10. When I equals to 2, the value is negative 14. When I equals to 3, the value is negative 8. Semicolon at the end. Okay, we are done with that part. A is the same, B is the same. Lower bound and upper bound for variable x is the same. You have defined your variable x, but now we have a new set of variables. It is y. If you write it like variable x like this, I in I, then you need to define a lower bound parameter, because it is y1, y2, and y3 greater than or equal to 0. So you need to define a lower bound parameter for variable y. But I'm gonna show you a new way to avoid defining a parameter like lj. You don't need it because all of them are 0. So instead of curve bracket I in I, I'm gonna use curve bracket y, just complete set of I. Avoid writing down entities small I in I. Just yi greater than or equal to 0, and that's it. It's gonna work. Here you cannot do that. For lower bound you don't have a problem, but for upper bound it was 9 and 6. So you need to you want to define the upper bound for each entity separately. So you need this small j. Here you don't need small I because all of them are 0. Your objective function is summation over j for cj xj. Now we have something more, plus summation over I. It was c1j. Now we have c2I multiplied by yi. Subject to a set of constraints, we need to modify these constraints. Its equation aij multiplied by xj summation over j equals to bi plus yi. Let's check the data section again. We have two sets, parameters c1, c2, a, b, l, and u. So let's run the model. Tools, check that generate output file on Go, and then run the model. Yes, it's the same solution as we had in previous type of modeling. Write down everything when whatever you see on paper. It was 84.9 and again we have 84.9.